Now we go to the example of composite bodies. Okay, uh, F97. In this problem, a straight wire with this length 300 plus 600 plus 400, which means that like 1.3 meter, right? It is bent at this and that. You see, bend first 100 at 300 millimeter, bend at this point, and then now it becomes like this, L, and then at 600 millimeter bend, and then you have another 400 millimeter, and then the angles, the 300 millimeter will follow X, and then it bend 90 degree, follow Y, okay, and then bend 90 degree downwards. Now you have this 400 millimeter following Z, okay. Actually, the way why this bend like this, so it'll be easier for you to calculate, okay. So the question asks to find where is the centroid. So what is the X bar, Y bar, and Z bar? The location of this centroid, of this wire band wire. Okay, so how to do this? Though actually the wire was actually a single body, now if you have bend it, so now it becomes a composite body. Can you see that this is the first? It's like three bodies now. This is the first, this is the second body, and this is the third body. Alright, so for the composite bodies, what we can do is we can find individually the centroid of these bodies first. For instance, the centroid of this one, the first one, where is the centroid? The centroid should be in the middle, right? Middle of 300, so it is here, isn't it? How about this number 2? The centroid should be in the middle of 600, so it is somewhere here, right? I'll locate this one first, and then we'll discuss. And then how about this 400 millimeter? Should be somewhere in the middle, so like 200 in the middle, right? Okay. So for the composite bodies, we can do this. We can make a table. For instance, you say that whatever segment, for instance, segment. Okay. Segment 1, segment 2, segment 3. Or you can say A, B, C. I mean, it doesn't matter at all. Okay. And then what is the length? Okay, everything is in millimeter, okay? We just keep that in mind. Everything in millimeter. The length for number 1 is 300 millimeter. For number 2 is 600 millimeter, and for number 3 it is 400 millimeter. But before that, let's go back for let's step back for a while. Why we want to do this? The reason is because your X bar is actually, in this case, it is summation of X tilde L over summation of L, because this is just a function of L, right? Same goes to Y bar. Y bar, it is summation of Y tilde L summation of L, and Z bar equals to summation of Z tilde L over summation of L. Okay, that's why we want to locate individually what is the X tilde, what is Y tilde, what is Y tilde, Z tilde, and what is the length, right? So now we go to the X tilde, Y tilde. So X tilde, the X coordinate of the centroid of segment 1, 2, and 3. So for this one, what is the X tilde? It is 150 millimeter. Positive 150 millimeter, right? How about number 2? Number 2, it is, the X is 300, right? 300. The Y will be in the middle, yes, but the X, it is 300 itself, from 0 to 300, right? Number 3, how much? The X tilde, it is 300, right? Same. If you bring down, this is 300. Okay? And then Y tilde, for X, for number 1, this one, Y tilde is 0, right? Because this is Y, positive Y, negative Y, so this is 0. Okay? For number 2, this is y equals 0, it's y equal to 600, isn't it? So it is in the middle, so it is 300. And for number 3, this one, the y coordinate of this centroid, where is it? It should be here, which is 600. Okay, again, this one is in the middle of 400, yes, but this is for the z, not for the y. Y is this, okay, 600, because 600 and then it goes down perpendicular to the y axis. Okay, then z tilde, the z coordinate of the centroid. For number 1, the z is 0, isn't it? Z 0 positive, z 0 negative. Okay, so this is z equals to 0. Number 2, again z equals to 0, right? And number 3, from this xy plane, z going down 200, isn't it? This is 400, so half of that is minus 200. Okay, minus 200. Why minus? Because we define z as positive upwards, so going downward will be minus 200. Okay, and then you can extend this table for x tilde L. Okay, actually this is the problem. Okay, we extend here, okay, the table, but because I don't have space, I'll put it here. So x tilde L, y tilde L, and z tilde L. Why we want to do this? Why we want to multiply them? Because of this, of this formula. So x tilde L, 150 times 300. 150 times 300, it is 45,000. Okay, this one. X tilde for number 2, okay, 1, 2, 3, alright? 300 times 600, so it is 180,000. This, and then x tilde L for number 3, it is 300 times 400. It is how much? 12. 120,000. It's okay. And then y tilde L 0 for number 1. For number 2, it is 180,000. Same like the x. And then so y tilde L for number 3 is 600 times 400. It is 240,000. Okay. And then for the z, 0, 0, and then this 200 times 400, it is minus 8. 1, 2, 3, 4, yes, 80,000 only. 400 times 400. Okay, minus 80, minus. Okay, and then you sum them up. Summation of x tilde L is how much? You sum them up, you will get 40,000 plus 800,000 and 80,000, sorry, plus 120,000. So you got 345,000. Okay, for x tilde L. So for y L, it is 80,000, 180,000 plus 240,000. So you got 420,000. I hope you can see this. ZL, okay, is definitely simply 80,000. Okay. And then what's next? Next we will put it into the equation, right? So for x tilde, x bar, it is this. Okay, another thing, forgot. Summation of L, okay, is 300 plus 600 plus 400. It is how much? 1300 millimeter, isn't it? Okay. So now we substitute into the equation. X coordinate of the centroid, x bar, it is x tilde L 345,000, right? And L is 1300. You hit a calculator, you will get 265.4. 265.4, okay, millimeter, right? So for Y bar, it is this 420,000 divided by L. Summation of L is 1300. Okay, use your calculator. It is 323.1 millimeter. Okay, and then ZL minus 80,000 divided by L. L is 1300. So 80,000. 61.5. So you got minus 61.5. So what happened here? You can locate that. Okay, 265x, so 0 to 300, so it is somewhere here, right? And then Y bar 323, so this is 600. 300 is half, 323 is slightly more than that. Okay, so it becomes here somewhere, right? And then the Z is minus 61.5, so this is 400. So 61.5 is like even less than 1/4 of that, probably 1/8. So become, go down a bit and then probably somewhere here. Okay, then this C is 265.4, 323.1 minus 61.5, which is the coordinate. Alright, can you see that actually the centroid of this bent wire, it is outside of the body. Okay,